All right, we're going to get started with our first video notes. These are our first notes for the class that actually include the content. And just a few things I want to remind you. First of all, make sure that your environment is quiet, that you can focus on this video. Make sure that you have, iPods turned off, iPhones turned off, phones turned off, log out of Facebook, no interruptions whatsoever. Turn everything off. If you're on a bus and you're driving out to a football game, then put your earbuds in so you can watch this on your phone. Do what you need to do so that there's nothing that's going to interrupt you in the middle. Okay? Now, you can gauge your time. So if you know right now I have 5 minutes, then make sure that you can actively engage for 5 minutes. Then remember where you are in the video, stop there, and come back to it later. You can break it up into bite-sized chunks, but make sure that you take the time to focus with each bite. Okay. Also, don't forget you can pause, rewind, and rewatch. So if I go too fast, you miss something, you're filling in your guided notes as you go. So make sure that if you miss something, you rewind it, you rewatch it, okay, pause if need be, and remember when we get to the practice problems, you want to pause it, try the problems, do the problems, and then start the video back up and see if you got it right. We learn by doing, and the more that you engage, the more that you do in these videos, the more you're going to learn it, and the more it's going to sink in, and the more you're going to get out of tomorrow when we get into class and we start practicing. All right, so let's go ahead and get started here. Let's see what we've got. So we are talking about the SI system. This is the International System of Units. This is the measurement system that is decided upon by scientists. Basically what they've done is they've gone through and decided for each type of measurement, for each quantity, this is the unit that we are going to use. That way, no matter where you are in the world, if you collect scientific data, you can share it with other scientists, and you can be assured that they use those units too, and they're not going to have to convert them into something really weird. It'd be the equivalent of us, I don't know, doing all measurements in cups and then sending that to a country that does all their measurements in milliliters. That would be really rough. You'd have to convert everything. So this makes things simpler. All right, so let's take a look here. We have different types of units that I want to talk about here. And there we go. There's my pen. A little tricky. All right, so first of all, these are our types of units. These are our quantities. We are going to be measuring things like length. We'll be measuring volume, mass, density. Now keep in mind, density I have on this. However, we are not really going to get into density until later on this unit. So while I'm mentioning it right now because it relates to these up here, realize you don't have to have a grasp on density for at least a few days, okay? And then later on, there's another video today that you're going to look at that relates to temperature. We'll talk about it briefly right here, but there's another video entirely that deals with temperature. So let's talk about these big three. These are the focus for this particular video. So we have length. Length is the distance between 2 points, right? So you're going to figure out how long something is. In science, we're going to measure that in meters, and the symbol for that is an M. Now, a non-scientific unit that does the same thing but with different values, and we don't use this in science class, would be something like a foot or an inch. Okay? Symbol-wise, there's different ways of writing it. I could say that I am 5 feet tall, or I could say that something is 6 inches, like, for instance, going to Subway and getting a 6-inch sub. Volume. Volume has to do with three-dimensional space. So 3D space. How much space does an object take up? Technically, the scientific unit for that is a cubic meter, because the formula for figuring out the volume of something is its height times its width times its length. These are all units, these are all measurements of length or distance. So technically, you would just take a meter, measure the height, width, and length, multiply those all together, and you'd get a cubic meter. However, in chemistry, because we don't always want to be measuring the length or distance of things, we use the metric unit, which is kind of the happy cousin of this SI system. SI system was actually figured out using the metric system. So what they've done is chemists have borrowed this guy here, and this is a liter. So for our purposes, the base unit of volume will be liters, although occasionally we will come across something that is cubed. Non-SI unit would be something like you've got a pool or something like that, and for some reason they did it in, say, cubic inches. Or they could say that it's in, another example would be a gallon, right? Tell you how many gallons of water are in your pool. Moving on, mass. Mass has to do with the amount of substance. It's the, technically, we haven't used this term yet, but it's the amount of matter. So the amount of matter that is in how much of the substance is there. The base unit that we will use is grams. Again, there's a little tricky thing here. Technically, the base unit of mass for the SI system is a kilogram. However, kilograms are really big, and most of our measurements in this class are not going to use kilograms because it's just too big. That's too much material. So we're going to measure things typically in grams. So our base unit will be grams. The symbol we use is a lowercase g. And a non-SI unit that would be similar to this would be something like a pound. So if you say, for instance, I would like a quarter pounder, you're saying that you'd like 0.25 pounds of meat in your hamburger. Symbol for that would be something like LB, right, for pound. Density, as I mentioned, density is something we're going to talk about later. What I do want to point out, though, is notice it uses metric or SI units. It's in grams per cubic per cubic centimeter. So notice this is grams is mass, right? So technically density is a relationship between two different measurements, a measurement of mass, and then the second one, cubic centimeters, just a smaller version of a meter, so that would be volume since it's cubed. If there was no cube, it was just centimeter, it'd be length. But because it's centimeters cubed, we know it's volume. So density relates mass and volume. We'll deal with these later. Density is a different lecture all entirely. Temperature. Now, SI unit here is Kelvin. However, we don't have a lot of Kelvin thermometers in this class. We use Celsius thermometers, which is another measurement of temperature that has been used traditionally with science. However, Kelvin is the SI unit. So what we will do is we will measure things in Celsius, and then we will convert it into Kelvin. And just so that you see, technically that's the symbol, and then how to spell it would be Celsius. Okay. Non-SI unit that is similar to temperature will be something like Fahrenheit, and I always misspell it. I really need to learn how to spell this one. But the reason why I don't know how to spell it is because we don't use it in science. We will not be using Fahrenheit. So don't use it, don't plan on using it, and you're fine. Celsius I can spell, Kelvin I can spell. We use those. All right. Okay. Let's talk about big versus small measurements. In the SI system, we need to be able to use measurements that reflect the size of the object that we're measuring. In other words, if I'm going to measure something big, if I'm going to figure out a quantity such as mass of a large object, something like an elephant or something like that, I want to use a big measurement. Just like if you were going to measure the distance from here to Seal Beach, you would want to use a big measurement. You don't want to, pull out a tape measure and start measuring it. You need to take forever. You need something that's going to measure that long distance. Okay. If you're going to measure something small, right? So for instance, if you were going to measure the size of a grain of sand, so something very, very tiny, that tape measure isn't really going to reflect it very well because chances are that the grain of sand is smaller than the lines on the tape measure, right? So we can scale, we can figure out measurements that are smaller or bigger than what we're used to reflect what we're trying to measure. Now, right here, notice this square is darker. Right in the middle here, these are going to be our base units. So things like grams, meters, and liters. These are the big three that will fit into this concept of scaling. And the way that we're going to scale them is we are going to add prefixes to their names. So what we need to learn is the prefix that is associated with the larger or the smaller measurement. And the reason why these prefixes are important is that they will tell us how many times we have scaled by a factor of 10. So let's do some examples. I'll show you what I mean. If I've got a gram, but I've got something large, slightly larger, and I really need a slightly larger measurement, I can scale it up by a factor of 10, and we call that a deca. So a decagram, okay, decagram is 10 times larger than a base unit. So base unit, think of that as 1. deca is 10 times bigger. Then, let's say I need to be slightly larger than that. This would be a hecto. So the hecto prefix goes in front of the base name. So this becomes a hectogram. Here's our abbreviation. And since it is 10 times bigger than a decagram, it is actually 100 times larger than the base unit. So our scaling, as we go up this way, is just increasing by a factor of 10. Our largest in this particular example would be a kilo. So that's a kilo prefix. We call this a kilogram, and we abbreviate it as kg, and it is 1,000 times larger than a gram. So that's getting bigger. If we go the other way and we want a measurement that is smaller than a gram, we can divide by a 10. So 1/10 of a gram would be deci. Okay, and we call that a decigram. Remember, this can be applied to any 3 of the original base units. So grams for mass, meters for distance, and liters for volume. Can use it for any. I'm just particularly, the example I'm using right now is for mass, so that's why I'm filling these in. So technically we put gram there, right? Because that's the base unit. So that's deci. Then if I need to get even smaller, I can divide this by 10 again. That becomes 100th. And this prefix is centi. Okay. The abbreviation would be CG, and we call it a centigram. And then the smallest, divide by 10 one more time. This becomes 1,000th, and the prefix, whoa, there we go, is milli. Abbreviation is mg, and the name would be milligram. Might have heard of those. We use those. They're commonly used with medications. When someone says, oh, I'm taking 250 milligrams of Tylenol or something like that. That tells you how much of the medication you're actually ingesting. So this is how we scale it. Now, we're going to need some practice with this, but this is the idea that to shift from one spot to another, you are simply just either dividing by 10 or multiplying by 10. All right.